For today's task, we're going to use a graphing calculator to solve a number of equations. In order to do so, what we're going to do is we're going to take this equation and split it up into two parts. The first part comes from this left side of the equation. We end up with y equals x plus 5 squared minus 13. And the second one will be y equals 7.221 times x plus 15. Now, when we put these into a graphing calculator, we will need to give them a different name. So instead of calling them by y, I'm going to use function notation. Call this first one f of x, and the second one I'm going to use function notation as well, but give it a name of g of x. That will allow us to put two separate equations into the graphing calculator and to find their intersection so that we can figure out what the solution is. I do want to keep in mind that in this original equation we're looking for the x variable. We've got x here and x there. So once we've found the x value, we are finished. So I've typed these two equations into a graphing calculator here. We can see over on the left side that we have those two equations written in function notation, f of x and g of x. Now I can't see both of them on the graph as of yet, so I'm going to zoom in and out here until I find the intersections for those two graphs. We can see that there are two places, one here and then one up there, where they intersect. We're going to find both of those, and we will have both of our possible solutions on this. To do that, I'm going to click on this Tools menu. I'm going to go to the Point tool here, and I'm going to put a point at each of those locations, the intersections. So there's my first one, and here's my second one right there. And if I go back to this algebra menu here, then we can see that we have 2 points at the intersections. We can see that they both say intersect with an x value and a y value. Now our original equation only cared about the x value, so I'm going to take the x value for each of these, which is negative 11.3 and 8.5, and those are our two possible solutions. So we have negative 11.3 and 8.5. 11.3 and x equals 8.5. Those will be our two solutions for this question. On this second one, we have again the two sides that we're going to split out into two separate equations. We'll just start with our function notation here this time. So we get f of x equals 1.2237x plus 107.5353. And then the second one, we're going to call g of x. That will equal negative 21.5904x minus 16.0051. Type those two equations into the calculator. By the way, the calculator that I'm choosing to use is GeoGebra from geogebra.org. And we can see those two equations right here. Again, I only see one equation, so we're going to zoom out here and we can see the intersection. So we'll find that intersection point, click on Tools, click on Point, put that point at the intersection, go back to the algebra list, and we can see our point right there. This one only has a single intersection point. They're two straight lines, so we only have one solution for it, and we're going to round that to negative 5.4. So this second one has a solution of x equals negative 5.4. All right, equation number 3 here. On the left side, we'll have f of x equals the absolute value of x minus 16. And on the right side, we have g of x equals 31.7. Let's go to the graphing calculator. We have both of those equations typed in here. I can't see either one, so let's go ahead and zoom out. All right, we have a horizontal line and an absolute value equation, which we can see there are two intersections for it. So we make sure that we find both of those. We're going to put a point here on the left, put a point here on the right, go back to our algebra menu, and we can see our two solutions are negative 15.7 for the x value here, and 47.7 for the y value here, or the x value in this one. So solution number 1, negative 15.7, And solution number 2, we have x equals 47.7. Those are our 2 possible solutions. For our next equation, we're going to separate this out again. On the left, we have f of x equals 11 over 100 times the absolute value of x minus 3 minus x squared minus 4. And over here on the right-hand side, we have g of x equals x to the 5th divided by 3. We have those graphed here, and we can see that the 2 intersect down here at the bottom left. This is steeper than that, so they're going to separate on this side over here, so we don't have any intersections up there. And then down here on the left, they're going in opposite directions, so it won't intersect again. So we just have that single intersection here, and that point has an x value of negative 1.57, so that's our solution. Write x equals negative 1.57. And our last equation here, we're going to split this side up. We have f of x equals x plus x squared plus x to the 3rd power plus 1/2 x to the 4th power. And the right-hand side, we have g of x equals 6 to the x power minus 1. Going back to our calculator, we've got both of these graphed here. We can see that there's an intersection there. I can't quite tell over on this side, so I'm going to zoom out and in a little bit, see if there's an intersection right there. And looking over here, I can tell that this blue graph is getting steeper than the green graph, so they are going to separate and not have a solution over on that side. So we're going to look down here at the bottom where they do intersect, zoom in, and we can see, if we put a point, that there is an intersection right here. It happens to be at the point 0, 0. So our solution for this one is x equals 0. And we just have the single intersection on that one, x equals 0. Now, often I have my students ask me, Mr. Fowers, if we have an x and a y value here for our solution, why don't we write down the y value as well? So just to repeat what I said at the very beginning, when we go to our original equation, we have only x values in this original equation. So the y value is just there to help us be able to graph these. I wouldn't be able to graph it on this graphing app without an x and a y value. So we've separated it out and given it a y value for each one. But when we are finished, we only care about the x value. So that's what I'm going to write down as my solution. The y value is helpful, but we do not need it anymore now that we have our solution. Thank you guys, and good luck.